Time feels obvious. It moves forward. It carries us from birth to death. It turns moments into memories. You never see time, but you feel it constantly. Every second that passes feels real, unavoidable, and absolute. But here's the uncomfortable truth. Physics does not agree with your experience. At the deepest level, we understand. The universe does not require time to move forward at all. The fundamental equations that govern reality work almost perfectly, whether time moves forward or backward. Flip the direction of time in the math, and nearly nothing breaks. Particles collide the same way. Forces behave the same way. Energy obeys the same rules. To the universe, yesterday and tomorrow are nearly identical. So where does the feeling of time passing come from? Why does life unfold in one direction? Why can you remember the past, but never the future? To understand this, we need to strip away assumptions. Time feels like a river flowing forward. But physics suggests something stranger. Time may not be flowing at all. It may be static. Imagine the entire history of the universe already exists. Every moment, from the first instant after the Big Bang to the last star burning out, laid out like pages in a book. You don't experience the book all at once. You experience one page at a time. But the pages themselves are fixed. This idea is called the block universe. In this view, the past, present, and future are equally real. The present is not special in the universe. It's only special to you. Your consciousness moves through the block, giving you the sensation of time passing, but nothing is actually moving. That sounds abstract, but it has real consequences. If time doesn't flow, then change doesn't happen because time pushes it forward. Change happens because the relationships between physical states are different on each page of the block. Time becomes a label, not a force, and this raises a disturbing possibility. If time isn't fundamental, then something else must be creating the direction we experience. Something invisible. Something deeper than clocks and calendars. We already know that clocks don't measure time itself. They measure motion. Vibrations in atoms. Oscillations in crystals. Orbits of planets. Every clock measures change, not time. Time is inferred. An inference can be wrong. Einstein showed us that time isn't universal. It slows down near massive objects. It slows down at high speeds. Two observers can experience different amounts of time between the same events. Time stretches, time compresses, time refuses to stay consistent. This alone tells us time isn't absolute. But it goes further. If time can slow down, then under extreme conditions it can nearly stop. And if it can nearly stop, then maybe it isn't fundamental at all. Maybe time is something the universe allows, not something it requires. And if that's true, then the next question becomes unavoidable. If time doesn't naturally move forward, why does everything you experience do exactly that? Why does the universe seem obsessed with turning the present into the past? The answer isn't time, it's something else. Something that gives direction to an otherwise directionless universe. The hidden mechanism that turns moments into memories. The reason the universe remembers yesterday, but not tomorrow. And why? Without it, time as you know it would not exist. If time itself doesn't naturally move forward, then the direction you experience every second needs an explanation. Physics has a name for this direction. It's called the arrow of time. And it's one of the biggest unsolved problems in science. At the microscopic level, almost nothing prefers a direction. The laws governing particles work the same, forward or backward. If you filmed two atoms colliding and played it in reverse, physics would struggle to tell which version is real. But zoom out to everyday life, and direction suddenly matters. You remember the past, not the future. Ice melts, but melted water never reassembles itself into ice. Smoke spreads out, but never gathers back into a flame. These processes clearly move one way. So where does this direction come from? The answer most physicists point to is entropy. Entropy is often described as disorder, but that's misleading. A better way to think about entropy is possibility. Low entropy means few possible arrangements. High entropy means many possible arrangements. A brand new deck of cards has low entropy. There are only a few arrangements that look ordered. Shuffle it, and entropy increases. There are vastly more ways for the cards to be mixed than neatly stacked. The universe behaves the same way. At the beginning of the universe, everything was incredibly ordered. Matter and energy were packed into a smooth, uniform state. This was an extremely low entropy condition. Since then, entropy has been increasing. Stars burn fuel. Heat spreads. Structures form, decay, and dissolve. Not because time pushes them forward, but because higher entropy states are overwhelmingly more likely. This is the real arrow of time. Not time itself, but entropy increasing. But this explanation hides a deeper mystery. Why did the universe begin in such a low entropy state in the first place? Nothing in physics requires it. In fact, a high entropy universe would be far more natural. Yet somehow, the universe started in the one condition that allows time to have a direction at all. Without that special beginning, there would be no past and future, no memories, no cause and effect, no life. Entropy gives time, its arrow, but entropy doesn't explain why the arrow exists. It only describes how it behaves. And this leads to a startling realization. Your experience of time isn't driven by clocks or cosmic expansion. It's driven by information. Every memory you have is a physical record created by increasing entropy. Your brain forms memories by rearranging matter into more complex, higher entropy states. You don't remember the future because there are no physical records of it yet. The past feels fixed because it's written into the structure of the universe. Time feels like it flows because information accumulates. But remove entropy, remove memory, remove irreversible change, and time collapses into a static landscape with no direction. In that universe, nothing ages. Nothing experienced before or after. Everything simply is. This means time, as you experience it, may be an emergent illusion created by deeper physical processes, a side effect of how information behaves in this universe. And if time depends on entropy and information, then controlling time isn't about controlling clocks. It's about controlling the conditions that allow entropy to increase at all, which raises a question far more unsettling than time travel. If entropy creates time's direction, what happens when entropy stops increasing? Then places where entropy behaves differently should also change how time behaves, and the universe has places exactly like that. They're not science fiction. They're not hypothetical. They exist right now. If you're enjoying this journey into the hidden side of the universe, consider subscribing. We explore science mysteries every week. And if this sparked your curiosity, leave a comment. Do you think time is fundamental? Or is it something that only exists because of deeper forces? Now, let's keep going. The first place time begins to fail is at extreme speed. According to Einstein's theory of relativity, time is not absolute. It stretches and compresses depending on how fast you move. The faster you travel, the slower time passes for you, relative to everything else. This isn't a trick of perception. It's been measured. Atomic clocks flown on airplanes tick more slowly than identical clocks left on the ground. Astronauts aboard the International Space Station age slightly less than people on Earth at everyday speeds. The difference is tiny. But as you approach the speed of light, the effect becomes dramatic. If you could travel at 99.9% the speed of light, years would pass on Earth while only days passed for you. And at the speed of light itself, time stops completely. Photons don't experience time. From their perspective, the moment they are created and the moment they are absorbed happen at the same instant, no matter how far they travel. That alone tells us something unsettling. Time is not a universal background, ticking away evenly for everything. It's tied to motion. The second place time breaks are near extreme gravity. Gravity doesn't just pull on matter. It bends space-time itself. The stronger the gravity, the slower time moves. This isn't theoretical. GPS satellites must constantly correct for gravitational time dilation caused by Earth's gravity. Without those corrections, GPS would drift by kilometers every day. Near a black hole, this effect becomes extreme. As you approach the event horizon, time slows relative to the outside universe. To a distant observer, you would appear to freeze, stretched and dimmed, never quite crossing the boundary. But from your own perspective, your clock would tick normally. This creates a paradox. Two observers disagree not only about how fast time moves, but about what events even occur. Inside a black hole, our current laws of physics collapse. Space and time swap roles. The future points inward. There is no path that leads back out. In these regions, time isn't just distorted. It may not exist in any meaningful way at all. And that leads to a disturbing implication. If time can slow, stop, stretch, and collapse depending on conditions, then time is not fundamental. It's a consequence. If relativity shows that time bends and slows, then quantum physics asks a far more unsettling question. What if time doesn't exist at the deepest level of reality? In quantum mechanics, the fundamental equations that describe particles don't require time to flow in a single direction. Many of them work just as well forward as backward. This creates a serious problem when physicists try to combine quantum mechanics with gravity. In some of the most advanced theories, including quantum gravity, time disappears from the equations entirely. There is no ticking clock beneath reality. Instead, the universe is described as a complete structure, a configuration where all possible states exist at once. Change, in this view, is not something happening over time. It's a relationship between different parts of this structure. This leads to the idea of a timeless universe, a reality where past, present, and future are not moving moments, but fixed locations within a larger whole. You don't move through time. Your consciousness traces a path through a structure that already exists. This may sound abstract, but it solves a deep contradiction in physics. Quantum mechanics allows particles to exist in multiple states at once, until they are measured. Time-dependent collapse doesn't fit cleanly into this picture. But if time is emergent rather than fundamental, quantum events don't unfold in time. Time unfolds because of quantum events. Entanglement pushes this idea even further. When two particles become entangled, measuring one instantly affects the other, no matter how far apart they are. There is no signal traveling between them, no delay. The correlation exists outside of time as we understand it. Experiments have shown that entangled particles behave as if the concept of before and after doesn't apply to them. Some physicists believe entanglement may be more fundamental than space-time itself. That space and time emerge from networks of entangled information. If that's true, then time is not the stage where reality plays out. It's built from information, from relationships, from correlations. Time may only exist where information can change, where systems can store records, and where entropy can increase. In regions with no change, no information flow, and no entropy growth, time may vanish completely. This helps explain why time feels so different at different scales. At the human scale, information changes smoothly, creating the illusion of a steady flow. At the quantum scale, reality jumps between discrete states, and time loses coherence. Your experience of seconds passing, memories forming, and moments stacking into a life may be a biological interface, a way your brain organizes information, not a direct reflection of how reality truly works. And if time is informational, then altering information alters time, not through time machines or paradoxes, but through entropy, energy, and quantum relationships. We are nowhere near controlling this. But the fact that physics allows the question tells us something profound. Time is not a master force. It is a consequence of deeper rules. Invisible forces are not just shaping time, they are creating it. If time is not fundamental, then the most unsettling question isn't how time began, it's whether time can end. Everything you experience as time is tied to change, to aging, to memory, to increasing entropy. Your body is not aging because time is moving forward. It's aging because entropy is increasing inside you. Cells accumulate damage, information degrades. Order slowly gives way to disorder. This is what we call the passage of time. But if entropy drives time's arrow, then a universe where entropy stops increasing would be a universe where time itself fades. Some theories suggest this is exactly where the universe is headed. As stars burn out, galaxies drift apart, and usable energy spreads thin, entropy approaches its maximum. This state is known as heat death. In a heat death universe, nothing meaningful happens. No stars form, no structures change. No information accumulates. Time may still exist mathematically, but experientially, it loses meaning. No before, no after. Just an endless, frozen equilibrium. Other theories suggest something stranger. That time could loop, that the universe could collapse and restart, resetting entropy and giving rise to new arrows of time. Or that multiple timelines exist, each with its own direction, its own version of past and future. There are even ideas suggesting time may fragment, that different regions of the universe experience different arrows of time, or that time exists only locally, wherever information flows. What's common across all these ideas is this: time is fragile. It depends on the conditions, on entropy, on information, on the structure of reality itself. And that means the forces controlling time are not clocks or calendars. They are invisible. They shape how the universe evolves. They shape how stars form and die. They shape how memories are created. They shape how you experience existence. Right now, you feel time as a steady flow, a moment turning into the next. But that experience is not guaranteed. It's a temporary feature of a universe in a very special state. A state that allows complexity, memory, and life. Without that state, time dissolves, which means something profound. You are not just living in time. You are participating in the process that creates it. Every thought you form, every memory you store, every irreversible change you make, you are helping define the direction of time itself. Time is not something happening to you. It's something happening because of you. And the invisible forces controlling time are not distant cosmic laws. They are woven into the structure of reality, and into you. Which brings us to the final question, the one worth sitting with. Is time something the universe is moving through, or something the universe is constantly creating? Let me know what you think in the comments. Thanks for joining me on this journey into the hidden side of the universe. Drop a like if this sparked your curiosity, and if this mystery intrigued you, you might enjoy what's coming next.